All right, welcome to Unit 7. Unit 7 is all about similar triangles and similar figures. And before we can get into that, we got to start off with learning a little bit about ratios and proportions. So let's start with some definitions. Our first blank here. A blank is a quotient of two quantities that have the same units. This is really what it's all about in this unit, and this is the ratio. So let's go ahead, fill that blank with the word ratio. Alright, since ratios are quotients, the denominator cannot equal 0. So remember, we can never divide by 0. Ratios can be written in two ways. We can start with the colon, and we read this as the ratio of 1 to 2. Or in mathematics, when we use these in this order, we would write it as a fraction 1 over 2. And notice, order matters. This is really important. If it's 1 to 2 here, then it's 1 over 2 as a fraction. All right, ratios are usually expressed in, and here's your clue, 4 to 8 is the same as 1 to 2, usually expressed in simplest form. So we're always going to simplify our ratios, and that's just like simplifying a fraction. Okay? So let's look at a couple examples. Now, let's say for this first part, example 1, that we have a class with 12 boys and 15 girls. So let's write that up here. 12 boys, get our pen back, and 15 girls. All right, so in this class, we're going to have one teacher. I know some of your classes have 2. Let's just say we have 1. Okay, so if we want to write the ratio of students to teachers, we have 12 boys, we have 15 girls. Altogether, we add those up. They're all students, so that's 27 to 1. And we could also write that as 27 over 1. All right, the ratio of girls to boys then. Notice, again, the order is very important, so we have to start with girls. 15 to 12, there it is, or 15 over 12. Now, when we see it as a fraction, it reminds us right away, all right, well, now I can simplify this fraction, right? 15 and 12, they both have have 3 as a factor, so we can divide out of 3. 15 divided by 3 is 5. And 12 divided by 3 is 4. So really, that's the same as saying a ratio of 5 to 4. All right, and finally, left-handed to right-handed. We don't have any information on that, so we're just going to say we don't know that one. We'd have to ask everyone in the class, and we don't know everything. So let's go ahead and continue. So now if you look at these ratios now in example 2, we have some units in here. So a lot of times we're using ratios to convert units, or we're using ratios between units, but we're measuring things. So this is 75 centimeters to 5 meters. So what we want to do is simplify, and this we are actually going to make a unit rate. So all we're going to do is simplify this fraction, and 5 goes into 75. So when I divide, I'm just going to divide each one of these by 5, and 75 divided by 5 gives me 25. Wait, that's not right. 75 divided by 5. 5 goes into 7 once, and then we have 15. That's better. So 75 divided by 5 is 15. So it's 15 centimeters for every 1 meter. And we'll write it like that. Okay, then our next one, we have 3 yards for every 6 feet. 3 yards for every 6 feet. If we simplify this, we see the 3 over the 6. 3 goes into both of these. We just divide by 3. Again, this is just like simplifying a fraction. So we have 1 yard up on the top, and we have 2 feet on the bottom. That's it. That's all there is to it. Keep those units with those, so that's very important when we're working with ratios. And now I have 6 feet for every 18 inches. I'm going to divide those by 6, goes into both. 6 divided by 6 gives me then 1 foot for every 18 divided by 6 gives me 3 inches. All right. Now we have some more definitions here. We're going to call this an extended ratio. This makes sense. Look at their definition. Extended. Extend something means to make it longer, right? An extended ratio is a ratio using 3 or more quantities that have the same units. All right, so when we write an extended ratio, we can write it something like this. We're comparing more than 2 things now, 3 or more, so I can write a ratio of 1 to 2, but now I'm going to compare another thing. So I just add another colon there, and I write a 3. Now notice we can't write this as one fraction because there's 3 things, but we could split it up into multiple fractions. Okay, so this is a ratio of 3 or more related parts. And I like to say related parts here because when we're using these in geometry, we're usually going to be talking about parts of a line segment, parts of a triangle, parts of some kind of geometric figure. Okay. All right, let's take a look at our next example. Given that AB, the ratio of AB to BC is 4 to 1. So notice now we're talking about these lengths. We have AB here, we have BC 4 to 1, and AC equals 30. So we have that marked on our picture. Find AB and BC. Okay, so when we see things in a ratio, this ratio has been simplified because we don't know what the exact thing is yet. So what we're saying is if I took AB, and I know this isn't a factor of 4, and if I simplified it, I've simplified out something like x. Okay, so all these problems you're going to notice when I'm dealing with a length or an angle or something like this, if it's a ratio of 4 to 1, I'm saying, well, this is 4x. Okay, and then here's BC, and that's 1, so BC is just 1x. So I have these 2 pieces, right? And now I know that AB plus BC is the same as AC. We can see that in our picture, right? So all we have to do is make a simple equation. So when you see the ratios, put the x with them, and write a simple equation. So I know that AB plus BC is AC, which is 30. So let's write our equation now. 4x plus 1x equals 30. Makes sense, right? Now we just simplify and solve. So 4x plus 1x is 5x equals 30. Divide by 5, divide by 5, and I get x equals 6. Now, this isn't our final answer. This is x. This is that factor that both of them are being multiplied now. So if I need to find AB, here's AB right here, right? AB is not x, AB is 4x. So AB is 4 times 6, which is 24. And there's one answer. And now BC is just 1 times x. So this one is just x, right? 1 times 6 are just 6. And there's BC is 6. And we can do a quick check, right? 24 plus 6 is 30. Awesome. All right. Now, a lot of these examples are going to be the same idea. So if you look at example 4, we have measures of angles in a triangle. And we have a ratios, right? We have 3 angles in a triangle. Let's not lose that one. We have 3 angles in a triangle. We have them at a ratio of 1, 2, and 3. So I like to draw a picture for these, even though I don't necessarily need one. But if I look at this, here's J, K, L. It doesn't matter where you put these things. Now, what does matter is this ratio. So, but we apply the same idea. The angle itself isn't 1 degree or 2 degrees or 3 degrees. It's 1 times some value, which I'm going to say is x. So that's 1x, that's 2x, and that's 3x. Okay? So now, what I do know about a triangle is that all the angles add up to 180 degrees. So again, all I'm doing is I'm looking to see how I can make an equation. So if I add up all my angles, 1x plus 2x plus 3x, that's all my angles added up. And I know that in a triangle, they always add up to equal 180 degrees. So there's our simple equation. Now all we have to do is go ahead and solve. So go ahead and solve that one. And I'll give you a second to do that, and then we'll go ahead and check our answers. Alright, you should have taken a second to pause that, and when you check your answers now, we should get these 3 answers. When you solve for x, we got x equals 30. And remember then, we have to plug these back in. So when we plug them back into each of our things, we get our angles to be 30 degrees, 60 degrees, and 90 degrees. All right, next one. Again, now notice, same idea here. We're looking to see how we can make an equation with this ratio. So here we have the ratio of AB to BC. Here's AB is our length, and that goes first. So that's going to be the 3x, and BC goes second. That's going to be the 2x. All right, now don't worry about the L and W right now. We're going to work with x's, but what we do know is that the perimeter equals 60. So you got to think, how do you find perimeter? perimeter. Perimeter is that length around the outside. So all I'm going to do is add up all these sides. So that's going to be 2x. And we can do this in any order. Plus 2x, plus 3x, plus 3x. What matters is that we have all four of those sides, and we add them up. We know that it's equal to 60. Okay? So again, take a second to solve this on your own. Pause it. Go ahead and solve it on your own. When we solve it, we get x equals 6. We plug it back in. Then we get our length, or AB, is going to be 3x, right? So that means our length is 3 times 6, or 18. Lost my pen here. And our width, when we plug that in, is 2x, which is going to give us 12. And we're given units here, so let's make sure we use our units as well. All right, so let's keep going. All right, we have another definition up here. Proportion. This is really important. Proportion is an equation with ratios on both sides. So when we take two ratios, we set them equal to each other. That is a proportion, and this is going to be really important when we're dealing with similar figures. Now, you guys have seen a lot of proportions before, but you may not even realize it. So the first important thing here, this is the cross product property, and this is where we're going to cross multiply. So make sure we got this straight in our head. We use cross multiplication when we see 1, 2 fractions and an equal sign. That's when we cross multiply. Okay, we cross multiply, we multiply the 4 and the x. Let me get rid of this, clean this up a little bit. All right, we're going to multiply the 4 and the x. Let's go ahead, 4 and the 7, sorry, not the x. And then we're going to multiply the x and the 5. So that's why we go across. And notice here's our equation. And when you cross multiply those, you got to put the equal sign. All right, now the reciprocal property, check this out. Look at what happens. If I reverse this 4 and the x down here, notice it's the same as what it was up here. So we can reverse these both to their reciprocals, and we get the same thing. All right, we know that's equal. The next one's the addition proportion. Check this out. There's 4 over x, but now look, instead of 4 over x here, I have 4 equals x on this side. Okay, we're going to show you why that works in a second here, but take notes of that in your note. Make sure that makes a little bit of sense. And let's go ahead and do example 6. All right, because this is our cross product property. You want to make sure we're good with this here, okay? So we're going to start with anything. Anytime you see a plus or minus in these fractions, put some parentheses around those. Okay? Now the reason that's important is because when we cross multiply, we're going to start here. Now that's really clear. I just do 3 times y, or 3y, right? Equals. Make sure you put your equal sign. But now when I do my other cross products, it's 2 times that whole thing. So when we write it, you got to make sure you write those parentheses there, because that tells us now we need to distribute that 2. Okay, so let's go ahead and distribute that 2 to both of those. And now we're going to go ahead and solve this thing. All right, so we got 3y equals 2y plus 4. All right, just a simple equation, right? Sorry, that got a little messy with the stylus. Let's try to clean it up here. Get my y's on the same side, minus 2y minus 2y. This is nice. 3y minus 2y is just 1y, or y, and I'm left with y equals 4. All right, not a bad deal, right? All right, now our next one here. Check out this next one. You guys should be able to do this one on your own. Take a second and pause it. Okay, again, we have a ratio. Okay, and we have now the value of x. So I'm going to set this up for you. This is kind of confusing because we've been using this idea of this ratio. Instead of this x here, let's get rid of that thing, and let's say I don't want x. I want to find the value of CB. Okay, CB, because now when I set up my ratio, I know that BC goes first. That's my 2. So that's going to be 2x, and then that's going to be 9x. All right, so this one's a little different. Let's go ahead and solve it. So our equation is going to be 9x is equal to 27. And that's really easy to solve. Divide by 9, divide by 9. I get x equals 3. Not bad. Now remember, I wanted to find CB, so I'm going to plug it right in here. And 2 times 3 equals 6. There's our answer. Not bad. All right, we're almost done. We got 2 left here. Example 8. All right, now check this out. This looks kind of weird. Okay, now what this is saying is to rewrite this. If we go back up here, notice I got the 5 here. Okay, I got the 5 here. I'm going to point with my tool. 5 here, 2 here, right? Now I got the 5 here, the 2 here. All right, if we look at this thing, okay, this should look kind of familiar to you, this pattern. And this pattern is up here in our notes, is this additional proportion property, all right? Now again, you don't need to memorize this thing, but what you need to be able to do is to understand why it works, okay? So all we're going to do is manipulate this equation and check out what happens. I see a proportion there, so right away I'm thinking, all right, I got a proportion. What am I going to do? I'm going to cross multiply. So there's the 5 and the 6. So I get 5 times 6. Now I'm not actually going to multiply it. I'm going to leave these alone because watch what happens. Equals. And then I'm going to multiply these two together. There's my 2 times my x. Now I want it to look like this, 5 over 2. So what I'm going to do is I'm going to divide this by 2 to get rid of that 2. Those cancel. So now check out what I have. I have 5 over 2 times 6 equals x. And now I can divide by 6. I'll do a different color here so you can see this a little better. Divide by 6, divide by 6. And there we go. 5 over 2 equals x over 6. And that's our answer. All right. All right, last one, and we're done with this lesson. All right, so this is what we're really going to be getting into with next lesson, is these applications. All right, so here we have this picture. In the picture, the building is smaller than it is in real life. Okay, so we have a small building that is 2.75 inches with a width of 1.875. So notice, here's a little suggestion. Draw a picture. It helps to see a picture. It helps to relate your parts. Okay, so as I look at this thing, let's draw a little building. And mine's going to be really messy, but I'm sure yours will be much nicer. And then we have our actual building, which is still kind of small, but let's label these things. So here's our little one in the picture, 2.75. All right, and a width of 1.875. All right, then we have this big one. The actual building is 26.25. All right, and we don't know the height, so that's where we're going to put our x. Whatever we don't know, or whatever we want, that's where we're going to put our x, or our variable. All right, now what we're going to do is we're going to set up a proportion with corresponding parts. So if I look at this, I'm going to set up a ratio first using height. Okay, so I'll start with the small building. In a small building, I'm going to take the height of the small building, 2.75, and then I'm going to take the height of the actual building, which I don't know. So that's x. So notice, the small building I'm talking about, that's in our picture, right? That goes on the top, and the bottom is actual. And what's important is that we always line these up. So now when we make our proportion, then we set it equal to. Now, we used height for this first ratio. Our second ratio now, we're going to use width. So notice I'm being very consistent here. Now there are a couple different ways we can set this up, but what's important is that you're always consistent with how you set it up. So I started with height, now I'm doing width. I started with my picture on the top. The width of my picture is 1.875. The width of my actual building is 26.25. All right, there we have a proportion. Now all we have to do is cross multiply, and we can solve. All right, so go ahead and cross multiply this. All right, you should have paused it. Let's get our answer up here then. I want to see your work. Make sure you are showing your work for this, okay? And our answer is just going to be x equals 38.5 inches. So yes, this is a small building. All right, that was 7.1. Thank you very much, and good luck with your practice.